Now we're going to look at solving quadratic equations by factoring. So the deal is, and the key word here is we're solving equations. When we were looking at factoring and all the prior stuff and all the videos of this factoring material, it was all looking at mathematical expressions. We were just looking at, say, a trinomial or a binomial or a four-term polynomial, and we were writing it in another form, a factorable form, by writing it in a few things multiplied or a couple things multiplied. So now in this case, we're actually looking at solving equations. So the difference between equations and expressions in algebra is when you're solving an equation, you're looking for the numeric answer, you're looking for the answer to these, so you're going to solve for the variable to find the unknown. And so I notice the equations because they have the equal sign. So the thing is with quadratic equations, later on in this course you will learn how to solve ones that are not even factorable. You will learn how to solve them by using something called quadratic formula or completing the square. Right now all these that you're going to see, they're going to factor. So we're going to use factoring. Factoring is the easiest, and it's the easiest way to solve these, and it's the first method you want to look for when doing these. We're going to use something called, that we all know, and it's actually called the zero factor property. And the zero factor property basically says if you have two things multiplied, any two things, like say 10 times 0, if you have two things multiplied, then one of those things have to be 0 or both. In order for that to be a true equation. And so say 10 times 0 is 0, 0 times 5 is 0, 0 times 0 is 0. So we use that to our advantage when we're dealing with factoring, and since we're writing as things as multiplied, what we do is we get one side of the equation equal to 0, and then we factor it to write it as two things multiplied, and then we know that the possible solutions for that, or the only solutions for that, are if that each factor is equal to 0. And so we can solve for those. And I'm thinking on these, when I'm looking at these quadratics, when we say quadratic equation, the standard form of a quadratic equation, ax squared plus bx plus c equals 0. And so I'm thinking, okay, there's two possible answers. There's a possibility of up to two answers. And so when I see this, my first step on all of these is get one side set equals 0. How I did that on this one, I just subtracted 4 to both sides. And so I end up getting x squared minus 4 equals 0. Now I focus on the polynomial that I have, and this one is difference of two squares. It's x times x, 2 times 2, difference. I know how to factor that one. That's going to be x plus 2 times x minus 2 equals 0. Difference two squares, so it's plus minus. What's being squared in front goes in front, what's being squared in back goes in back. Now you just have to take it one step further. So it's just like factoring, but now you take it one step further and go, okay, I need to know what x is. I'm solving for these equations. So I take each factor and set it equals 0 using the zero factor property and solve for my variable in each of the factors. To solve for x here, you subtract 2 to both sides. Solve for x here, you'd add 2 to both sides. And so my answer should be -2 and 2 in my two solutions. And that's it, or you could just circle that. On this one, I have an equation. I don't have one side set equals 0 again, so I want to bring that constant term over. And so that's what I'm going to do, is add 2 to both sides, write it in factorable form. It's in descending order, it looks good. I see that this is a trinomial, a is 1, cool, those are the nice kind. I can go, okay, factor this the quick way. This is a w, this is a w, because that's a is 1. What multiplies to be 2 adds to be -3, -2, -1. Set each factor equal to 0. And solve for your variable. So 1 and 2 are your two solutions. This problem right here is a great problem, you know, because we get it factors really nice. It's a really nice thing, but you can also visually look at it and go, okay, yeah, I do see if I plug a 2 in here, 2 minus 2 is 0, which is going to wipe that whole thing out and makes it a true statement. If I plug a 1 in here, 1 minus 1 is 0, wipes that all to be 0, and I see that it's a true statement. Those are the two solutions for that, that equation. It's always a good idea to check your answers, so you could plug 2 into this original and 1 into that original just to make sure you get negative 2 on the side when you plug those both into the variable to match up with that negative 2, and you should. And now, little harder factoring problem. A is not 1, it's a trinomial. I'm looking at this, I'm like, okay, well, I know how to factor these, and so what I'm going to do is I'm going to use crisscross. I'm going to try 3x and 2x. Let's see, 12, maybe I'll try 3 and 4. I'd have to stick the 3 down here and the 4 here if I'm going to do that. And I'm going to try crisscrossing them, see what we get. So we end up getting 8x here, 9x here. Is there any way to end up with negative 1x with signs that are opposite because of that minus? And there is. Plus, minus. So I stick those in. And I just factored that thing. Now if you did different methods, it probably would have took you a little longer, like the AC method, but it'll work. Either whatever method you need to use to factor that thing. Now I write those factors, set them equal to 0, and then take each factor, set it equal to 0, and solve for the variable in the factor. So 3x should equal negative 4, and then in this case I should get x equals negative 4/3 by dividing by 3 to both sides. This one I should get 2x equals 3, and then x should equal 3/2. There's my two answers. And so we should end up with negative 4/3 and 3/2 are the two answers that'll work for that equation. And so that's how you solve by factoring. I also would like to throw one more example at you because I was just thinking about this. You see some other types in the book where they try and trick you. Just remember, you got to have that one side set equals 0. The 0 factor property is the key on this. So that's what we were doing here, getting the one side set equals 0 and everything, but they're going to throw problems at you like this as well. So let me write one up here and then we'll finish out with this one. So if I give you something like this, x plus 2 times x minus 3 equals negative 4. And so if I have something like that, it's like, oh man, it looks like it's factored already. Can't I just set this factor equal negative 4, that factor equal negative 4 and call it good? No, that's not a property. The property is that it has to be set equal to 0. So you got to re-expand this out, reorganize it, refactor it then when the one side set equals 0 and then solve. So on this one, since it's not equal to 0, it's not really factored. We need everything involved for the factoring. So I use my distributive property. I end up getting x squared minus 3x plus 2x minus 6 equals negative 4. Combine my like terms, bring my negative 4 over. So I'm going to add 4 to both sides to make that 0 on that side. Combine my like terms here. I should get x squared minus 1x minus 2 equals 0. Now that's your new problem, and that's the problem we need to solve. We have polynomial equals 0. Factor this thing. I know it's x and x. What multiplies to be negative 2 adds to be negative 1. Be minus 2 plus 1. Set each factor equals 0 and solve. And that's it. Read my writing there, but that's it. So x equals 2 and x equals negative 1. And so that you'll run across problems like that as well. The books a lot of times will try and get really tricky with it, but that's the general basis. And that's everything about factoring. In all the videos now, you should have looked at how to attack factoring by number of terms. Always look for the GCF. And then we went over in each of the videos how to factor each of the types. 4-term ones, 3-term ones, A is 1, 3-term ones, A is not 1. 2-term ones where they're dealing with the squares, 2-term ones are dealing with the cubes. And then solving equations by factoring.